Hi everyone. In the previous class, we have seen the concept of multiplexers. Multiplexers means which is going to take 2 power n lines as input. Am I right? Yes, 2 power n lines as input, and it is going to produce one line as output. Right? So how it is going to produce only one line as output? That is because of various kind of controlling lines. Controlling lines, or I can call it as select lines. Right? Yes. Right? And we have seen that every multiplexer is a functional complete. Functionally complete. So why I am calling it as functionally complete? Because with the help of multiplexer, I can able to derive any kind of basic kit, or I can able to implement any kind of Boolean function. That's the reason I am going to call it as functionally complete. And also we have seen how to construct half adder, full adder, or half subtractor, full subtractor, along with various kind of examples, right? Yes. And also we have seen how many m by 1 mux are required in order to construct n by 1 mux, right? This is also we have derived one particular formula, right? And also we have seen one kind of segmentation example, right? If you are going to take 7 segment display, how it is going to be? It will be like this, right? Right. The one of the best example for that 7 segment display is this example, right? If you are going to take here, consider 12, 57, 26, you can able to observe everything, every digit will be a kind of 7 segment display, right? So digital clock is the best example for 7 segment display. Okay. Now in today's class, we'll see one more concept, that is de-multiplexers. Okay, fine. See guys, so multiplexer means it is going to take 2 power n lines as input, and it's going to produce one line as output. Whereas coming to demultiplexer, which is going to take one line as input, I can call it as I, and it is going to produce 2 power n lines as output. 2 power n lines as output, I can call it as demultiplexer. Basically, I can call it as 1 by 2 power n DEMUX, right? But the thing is, you need to produce some kind of control lines, as you know its meaning, right? So you are going to have n number of select lines are there. If you are going to have 2 power n outputs, right? Fine. For example, if I take any kind of a multiplexer which is of size 1 by let us take 2 power 1, 2 power 1, meaning that we are going to have 2 lines as output and 1 line as input, and you are going to have how many control lines are there here? 1 control line will be existed, right? Let I am going to call it as y0, and I am going to call this one as y1, right? Yes. So if you would like to get the value of y0, on what base you are going to get? Based on the controller it is going to produce, right? Based on the controller you can call it as s0 bar I, and for getting the y1 you can write it as s0 I, right? So how we are going to get this one actually, right? If you are going to have s0 as the select line, the possible values of the select line are 0 and 1, 0 and 1, right? So to get y0, here my value will be I, and here my value will be 0. Similarly for y1, here for s0 it will be 0, meaning that it won't be selected, and for 1 it will be selected, right? If you are able to solve this one, you can be able to get the same expressions only, right? This is what I can call as characteristic table, and if you are going to combine these two, I can call it as characteristic equation of the 1 by 2 demultiplexer, right? How we are going to construct this circuit for this one? If I am going to have one AND gate which is having the input I, and you are going to have one more AND gate which is having the input I, and the another input is s0, which I am going to make it as not and given to the first AND gate, and thus s0 will be given as usual. Okay, now I am going to get like this, right? This is, I can call it as y0, and this one I can call it as y1, right? That's it, right? If you are able to simply observe, it look like, if you are going to combine all the things, like this, you are going to get like I am trying to make it some kind of modification. This will be also connected like this, and we have given the variable value as I. Now is it look like a kind of 2x1 multiplexer or not? Yes. Now sorry, it should be a kind of 1/2 multiplexer. 1/2 multiplexer, right? So if I am going to redraw again, you are going to have an input line. That input line is going to be like this, right? This is y0 and it will be y1, and s0 will be moved like this, s0, and which is a complement, and this s0 directly moved like this, right? Now if you clearly observe, which is like 1/2 mux, because 1 is input and 2 lines are output, and there will be one select line. I can call it as 1/2 mux. 1/2 mux. Guys, if you are able to draw the circuit for 2/1 mux, what is the respective circuit you are going to get? So you are going to have basically two inputs. Am I right? Two inputs. One is I0, another one is I1, and for both of these, you are going to have one kind of NOT gate. Am I right? Yes. This will be controlled by S0, and you are going to combine these two as one line. You are going to get the respective output, right? Yes. Guys, this is a kind of 2/1 mux. 2/1 mux. Guys, is there any relationship between this 2/1 mux and 1/2 mux? Yes, you can able to observe, guys. If I am going to remove this OR gate, if I remove this OR gate, what is going to get? You will get the structure will look like this. This is important initially. That's why I am going very slow. And if I remove the OR gate, you are going to get y0 and you are going to get y1. And these y0 and I1, they make it as one input. That is I. And this will be as S0. If you are able to observe, now these two are completely same. Means how we are going to get demultiplexer with help of multiplexer? You can just simply remove OR gate and combine all inputs into all inputs, right? These are the 2 points you have to make sure to understand to convert the multiplexer into demultiplexer.